At this point, you should know the different deployment options or runtimes of Atomsphere, but we want to take a look at the options from the enterprise architecture perspective. The Boomi Atom Cloud is a multi-tenant, multi-node Atomsphere runtime engine. It is managed and maintained on Boomi servers by Boomi Resources. There is no local deployment in your architecture. It is a highly secure and scalable solution for implementing integration between online application systems and endpoints. A simple local atom can be installed in your environment to connect with on-premise systems as well as online applications and tuned to handle very large data volumes. The data is stored locally and the server setup, configuration, management, and monitoring and network traffic are all managed locally as well. Some customers employ a hybrid approach where some processes run on the Boomi Atom Cloud and other processes run locally on an Atom. Establishing both a local and cloud environment can help during transition from legacy to cloud-based operations. A molecule can be installed locally with multiple nodes to process a large volume of documents and records while maintaining high availability and load balancing. The molecule requires a server for each node along with shared storage for the main molecule directories. This simple table outlines some deployment options available to you. The Boomi Atom Cloud maintains the atoms for the client and could be a great solution for connecting to cloud applications. If any endpoints are on-premise, a local atom is required. This local atom can integrate between cloud and local endpoints. The server and setup management is the responsibility of the user. You could pursue a hybrid approach that uses the Boomi Atom Cloud and a local atom. Segmenting your workflow in this way can have advantages. A local molecule assures high availability and high volume performance. And the cloud molecule is a private cloud suitable for very large enterprises. It offers multi-tenant support and is an appropriate solution for white label independent software vendors. Let's touch briefly on local atom placement. This image illustrates a common architectural design for inbound web service requests implementing Atomsphere. The local atom is installed on a server inside the internal firewall, while the load balancer or reverse proxy is in the DMZ to receive the inbound requests. So, is that the right placement? Should the atom be installed in the DMZ or internally? The answer is that the atom should always be within the internal firewall with the other servers, databases, and applications. So you want to install the Boomi runtime within the internal network and not the DMZ because this is less configuration. In the DMZ, you would need to configure internal firewall rules for every endpoint that Boomi needs to connect to versus a single one from the DMZ to the load balancer proxy. You should consider the Boomi runtime as an app server with access to all backend apps. Also, don't forget that real data is persisted within runtime and requires security considerations. So don't use a second atom as a pass-through proxy in the DMZ. At the least, you would have additional execution latency as well as deployment, monitoring, and maintenance. And you would still need dynamic endpoint discovery, status, and routing heuristics, not a responsibility of a web service client connector. So if you need a proxy, use a proxy. Do not use the Boomi Atom. Let's review a few common architecture issues. If Atomsphere is a utility knife that can be used in different ways and in different situations, then you will need to make decisions about how and when to use it. This table is provided as a review and possibly to start a conversation in your team about this tool. The first task would be to identify all your endpoints you want to integrate and consider which are cloud and which are local. You would also want to determine if it will be batch or scheduled or real-time processing. When you have multiple end systems, should the integration be multiple point-to-point processes trading the same data, or utilize MDM? Is this a one-time or periodic migration, or is this an ongoing process? And can you determine the volume of data? There may be different types of error handling based on the volume size or endpoints. Can you rerun an endpoint, or can the source resend? And how can the integration recover from failures? And lastly, is some return notification required? Some other architectural issues revolve around AtomSphere's differences from other application or integration development software. Consider that AtomSphere and the platform may not fit current policies and standards if they are based on legacy systems or code-based software. So versioning is critical, and in a code-based environment, different techniques are adapted into the workflow. But in Boomi, versioning is done at the process level simply by deploying the process. Similarly, source control is at the component level by saving and having versions of a single component. Lifecycle development is tailored to the process and its movement through the environments, but this is also unique in the way which processes are deployed and copied to different environments. Ultimately, new policies or standards may need to be agreed upon instead of trying to fit AtomSphere into standards and practices that do not apply to it.